everyone, and welcome back. Today we're going to look at making simple procedurally generated terrain. So if you watched my last video on No Man's Sky, you'd know that we can use fractals to make environments, and while fractals can be a crazy topic to tackle, we don't need that kind of complex math necessarily to generate infinitely many mountains and valleys. Brownian motion is often used to simulate the seemingly random activity of particles moving and colliding in fluids like water or air. Now, I could do a ton of episodes on randomness and what true mathematical randomness means, but in this case, we can use the randomness of particle motion and use a specific generalization of Brownian motion called Perlin noise. We can use this noise to generate 2D images that act as a map for our terrain. In this case, we've set each pixel to some value between, let's say, 0 and 1, where 0 is black and 1 is white. So if this represents elevation, then our mountain peaks will appear at the white blobs, our flat sea level ground in the mid-gray tone at 0.5, and we could have lakes or canyons at the black blobs, since they represent negative elevation. For now, let's treat the noise function as a black box, meaning we don't know the internals, we don't know exactly how Perlin noise is calculated, but we do know that if we give it two numbers related to a location, a position on our map, it will spit out the value our elevation should be, and it'll spit out the same value given the same inputs, meaning it's deterministic. So we're also going to treat this as kind of like a wave function, where we can affect the frequency or wavelength by multiplying a constant to our inputs and affect the amplitude by multiplying a constant to our result. Now, some of you may remember waves from math, some may not be there yet in school, and some of you use them every day and find them easy peasy. So as a really quick refresher, equations like sine of x and cosine of x represent waves. Amplitude tells us how tall or short the waves are, and frequency tells us how many times a wave completes a cycle per second. Frequency is also related to the wavelength, so waves with higher frequencies and small wavelengths will look very thin and pointy, while lower frequencies and longer wavelengths will look more wide and rolling. And we see this in our own mountains and valleys. But everything seems too smooth, like a bunch of random waves kind of mashed together, not like anything in real life. So one way we can make things more realistic is by overlaying multiple noise maps on top of each other. We can adjust the frequencies with different amplitudes to weight how much we want each one to be expressed. So for example, we can have low frequencies as our base, so we have more rolling mountains, and add higher frequency values with a smaller amplitude to get those little rocks and crags in our result. And even though right now we just have a bunch of mountains and valleys, there are a bunch of ways we could build on this to make a map more suitable for a game. For example, we could assign different terrain and textures purely based on elevation, like that we have snow at values above 0.9 and water at values below 0.1. Maybe there's forest from 0.3 to 0.6. And if you see a game like Civ, there are tons of different variables and options you can adjust that changes what the map looks like. Things like the islands, moisture, resource distribution, if it has a tropical climate. We could have, in our game, multiple noise maps, some deciding elevation, some deciding resource distribution, and we could have different codes relating to different biomes like forest, desert, or tundra to decide which textures and objects should correspond to those grayscale values on our noise maps. But finally, the real key advantage to this technique is that we can deterministically calculate what a value should be given a position on the map, meaning we only have to remember the formula along with any frequencies and amplitudes we chose. This also means that for a huge game like No Man's Sky, all you need to remember is the formula, the variables, and a log of changes players have made to the planet, and that's all you need to keep generating and generating over and over again. So in my last video, I was talking about a key. This is basically what that key would be, and you only need to make a new key if someone discovers the planet, so there will never be all 18 quintillion keys showing up somewhere in a data center in the world. Anyway, some other differences with No Man's Sky. The generated terrain is mapped to spherical coordinates instead of rectangular ones, and you're on a rotating planet, and I think they even simulate gravity and things like that. And then there are the plants and animals, which to my understanding are basically a bunch of parts and textures pasted on different animation skeletons. But of course, there's so much more to this topic, but I hope you can see how you could make your own procedurally generated maps with relatively simple functions and concepts that you could find easily packaged in like Python or JavaScript. So if you want more on the implementation, how to iron this out in code or understand what Perlin noise is actually doing, I want to give a shout out to Amit Patel at Red Blob Games. He had some amazing interactive and clear articles on terrain generation and a bunch of other game dev topics, so definitely check out his site since there's no point in me reinventing the wheel when he has some really great material. But if you want some more motivation to try this out yourself, then I'll be extending the current AI Game Dev Challenge on r/TheHappieMakers for 1 month until September 30th at 11:59 p.m. over on r/TheHappieMakers. Doesn't matter if you've never made anything before, doesn't matter if you've never coded before, it's non-competitive. You could generate maps or make an AI that navigates through random mazes. The theme is very loose, and you could submit anything big or small, any tools or languages. I'll feature it on my second channel no matter what if you send something relevant that you made yourself. Anyway, have a happy day wherever you are. I'll see you guys soon. Bye!